Okay, for example 4, again we're finding y prime and evaluating it at the given point. Well, the derivative of the natural log of y, the derivative of y is 1 over y, and then it's times y prime. Equals the derivative of 2y squared, using my power rule, is going to be 4 times y to the first power times y prime. Minus the derivative of x is equal to 1. So just to clean this up, we have y prime over y is equal to 4y y prime minus 1. Then I get all my y prime terms on the same side. So I'm going to say y prime over y minus 4y y prime is equal to negative 1. Then I notice that I have a y prime in both of these terms, and I can factor out the y prime. So if I factor out the y prime, I'm left with 1 over y minus 4y, and that equals negative 1. Divide both sides by that 1 over y minus 4y, and I end up with y prime is equal to negative 1 over y minus 4y. And most people don't like complex fractions. Complex fractions are fractions inside of another fraction. So the way you get rid of a complex fraction is you're just going to multiply everything by that denominator. Well, my denominator is just y, so I'm going to multiply each one of these terms by y to clear the complex fraction. So I end up with y prime is equal to, well, negative 1 times y is negative y. Here my y's cancel, and it's just 1 minus 4y times y is a 4y squared. So y prime is equal to negative y over 1 minus 4y squared. Then what I want to do is I want to evaluate the derivative at the point 2 comma 1. So y prime evaluated at 2 comma 1 is going to equal, well, everywhere there's a y, I write 1, and everywhere there's no x's, there's only y's, so I'm only going to write 1's. So we end up with negative 1 over 1 minus 4 times 1 squared. So we have negative 1 over 1 minus, well, 4 times 1 squared, well, 1 squared is 1, and 4 times 1 is 4. So we're looking at negative 1 over negative 3. Well, my negatives cancel, so I end up with 1/3. So the derivative evaluated at the point 2 comma 1 is equal to 1/3. Let's look at example 5. Example 5 says, find x prime for x is equal to x of t, defined implicitly by the given equation, and then evaluate x prime at the given point. So what's happening here is that it wants us to find x prime for x is equal to x of t. So this is just a way to get you accustomed to the fact that since we're changing the variable, because we're used to y equals y of x or f of x, because f of x is the same thing as y, right? So we have a function in terms of x. Well, this is going to be kind of like a function in terms of t. So everywhere there's a t, we're good. But everywhere there's not a t, every time we take the derivative of an x term, we have to write x prime. But it's the same thing as we had before. So if I want to take the derivative of x cubed, we're looking at 3x squared, and it's a derivative of an x term with respect to t, so times x prime. Minus, well, this guy here again is a product, so we have to deal with it as a product. So I'm going to actually erase my minus sign, and then on the side over here, deal with the product, and then write in all information. So when I have products, I make this a plus and negative. So I'm going to say that my first term is going to be negative t. So my first term is negative t, and my second term is going to be x squared. So my second term is x squared. So the derivative of my first term, f prime, is going to be negative 1. And the derivative of my second term, s prime, is going to be 2x times x prime, because it's the derivative of an x term with respect to t. So putting it all together, we'd end up with plus, so I'm taking the derivative of this, and again, it's a product rule, so it's going to be the first times the derivative of the second plus the second times the derivative of the first. And now let's just finish this off. The derivative of -4 is 0, and the derivative of 0 is 0. So let's solve this for x prime. Let's first try to clean this up. So 3x squared times x prime is just going to be 3x squared x prime. Here, if I multiply, this is going to be minus 2xt x prime. And then over here, if I multiply, this is going to be minus x squared equals 0. So just like in our last problems, everything that has an x prime is going to stay on one side of the equal sign, and everything that doesn't is going to move to the other side. So I have 3x squared x prime minus 2xt x prime is equal to x squared, moving this guy to the right. Then I need to factor out the x prime from both of those terms. So if I factor out the x prime, I'd be left with a 3x squared minus 2xt. So divide both sides by that 3x squared minus 2xt, and x prime is going to equal x squared over 3x squared minus 2xt. So the derivative of that equation is going to be x prime is equal to x squared over 3x squared minus 2xt. Then what I need to do is evaluate it. Evaluate my x prime at the given point. Well, that given point is -3, -2. So this is my t and this is my x. Because remember, it's x of t, so the input value is t, the output value is x. So everywhere there's a t, instead of writing t, I'm going to write -3. And everywhere there's an x, instead of writing x, I'm going to write -2. If I try to evaluate this, I'm going to end up with -2 squared over 3 times -2 squared minus 2 times -2 times -3. Okay, now let's just work this problem out. -2 squared in my numerator is 4. And then this is going to be 3 times -2 squared is 4, so 3 times 4 is 12. And then we have -2 times a -2 is a +4. And a +4 times a -3 is a -12. So I get 4 over 12 minus 12. Well, 12 minus 12 is 0, and I get 4 over 0. But that doesn't make sense because that's undefined. So what we would say is that we are not defined at the point -3, -2. So we're not defined at the point -3, -2. We can't evaluate x prime at that given point. All right, let's move on to the last one, number 6. So number 6 is more of kind of what we were doing before. We want to find y prime. We know how to do that. We have to do implicit differentiation and then find the slope of the tangent line to the graph of each equation at the indicated point. So we need to find the slope of the tangent line at the indicated point. Well, that just means plug in 0, 0 and evaluate the derivative at 0, 0. So let's start with the derivative. Now, e raised to the xy. Well, xy, x times y, is a product. So when we take the derivative there, we're going to have to use the product rule. So remember, the derivative of e to the u is going to be e to the u times u prime. So the problem is when we take the derivative of x times y, that u prime, we have a product. So we have to deal with that. So I'm going to start with dealing with that before we get to actually taking the derivative. So I'm going to call x my first term, and I'm going to call y my second term. So now the derivative of x is 1, and the derivative of y is 1, but I just took a derivative of a y term, so I have to write y prime. So now let's take the derivative of this thing. So the derivative of e to the xy is e to the xy times the derivative of xy. Well, the derivative of xy, remember, is a product. So now let's go to the product rule. So times the first times the derivative of the second plus the second times the derivative of the first. And now I need the derivative of a negative 2x. Well, the derivative of a negative 2x is negative 2 equals. Now I need the derivative of y. Well, the derivative of y is 1, but I just took the derivative of a y term, so I write y prime. And then plus, well, the derivative of 1 is 0. And let's clean this up as best we can now. So we have e raised to the xy times, and here, well, x times 1y prime is just going to be xy prime. And this is minus 2, and it equals just y prime, because we don't need that 0 there. We need to get all their y primes on the same side, but the problem right now is that we have a product going on over here on the left with a y prime. So the first thing we actually need to do is distribute. And after we distribute, we can get all our y primes together. So the first thing we have to do is we have to distribute. So let's start by distributing. So e raised to the xy times xy prime, when we multiply that in, it's just going to be e raised to the xy times xy prime. Plus e to the xy times y, when we multiply that, that's just going to be e to the xy times y. And still minus 2 equals y prime. So now everything with a y prime needs to get on the same side of the equal sign. This guy's got a y prime, and there's a y prime there. So I'm just going to move this over to the right. So I'm going to subtract e to the xy times xy prime. So we end up with, and I'm going to stick this y in the front, just because it's easier. So y e to the xy minus 2 is going to be y prime minus, and again, I'm just going to stick these guys in the front. I'm going to move it before the e to the x. So xy prime, e to the xy. So again, you notice here that I've got some y primes. So I can factor out a y prime from the left. So I have y e to the xy minus 2 equals. If I factor out a y prime, I'd be left with, well, a y prime from y prime leaves 1 minus, and the y prime from an x, y prime e to the xy leaves an x times e to the xy. Divide both sides by that 1 minus x times e to the xy. And we get that y e to the xy minus 2 all over 1 minus x e to the xy is equal to y prime. So now what we want to do is find the slope of the tangent line to the graph at the indicated value, so at 0, 0. So that just means we're going to evaluate y prime. This is the first part. So evaluate y prime at the point 0, 0. So we say 0 times e to the 0 times 0 minus 2 all over 1 minus 0 times e to the 0 times 0. Well, 0 times anything is 0 minus 2 over 1 minus, and again, 0 times anything is 0. So you're looking at negative 2 over 1, which is negative 2. So we end up with negative 2 is the slope of the tangent line at the point 0, 0. Negative 2 is the slope of the tangent line at the point 0, 0. That's it for section 3.5.